Today we are going to discuss about a new topic, which is giant molecule structures. So in these giant molecule structures, we have three parts. Okay, in this part one, I will intro to you what is macromolecule and what are the types of, or what are the example of the giant molecule. So here in this table, okay, we have three kinds of bonding. First one is ionic, okay, and the structure for ionic usually we call it as giant ionic, and the example for the ionic is sodium chloride. Okay, so this is the structure of sodium chloride, and then we have a covalent. So in this covalent, we have two kinds of covalent bonding that involve with two structures. Okay, first one is the simple molecule, for example water, and second one is the giant covalent, for example diamond. So this is the structure of the diamond. And then third one is a metallic, okay, and the structure is giant metallic. For example, here we have iron. So the bonding and the structures actually explain the properties of a substance. So what is macromolecule crystal, or what is a macromolecule? It is actually a big molecule that contains a network of covalent bonds binding its particle, and usually these particles are from non-metal atoms. For example, the examples of the macromolecules here, we have graphite, we have diamond, silicon carbide, silica, and also boron. So these macromolecule structures are always solids, okay, at room temperatures or at room conditions. Okay, so the macromolecules also form from the long chains of molecules containing a very large number of atoms. And then we have a few examples for the macromolecules other than graphite, diamond, and so on. We have plastics, proteins, and also some carbohydrates. So the higher the melting point or boiling point, they have higher melting point or boiling point compared to the simple molecules due to much stronger van der Waals forces. Other than that, they have a large molecular weight, okay, if we compare with the simple molecules. So in this topic, we focus on two giant covalent structures. They are, first one, in part 2 we will discuss about diamond, and in part 3 we are going to discuss about graphite. Have you ever heard about allotropes? Allotropes are different forms of the same element with their atoms arranged differently from one another. So they actually exhibit different behavior and also characteristic. So it is a behavior exhibited by certain chemical elements, okay, and these elements can exist in two or more different forms known as allotropes of the element. Okay, in each different allotrope, the elements atom are bonded together in different manner. So the condition that actually changes the allotropic forms are usually pressure, temperature, and also light. Okay, for example, okay, here we have carbon. Okay, in order to turn the carbon into diamond, we have to heat graphite to a very high temperature under great pressure. It is usually to stimulate the condition about 140 to 190 kilometers down in the earth mantle where diamonds are formed. So for example, let's say we have graphite, we have diamond. They are both made from the carbon, okay, but with different arrangement. Okay, so when they have different arrangement, they are going to have different behavior and also characteristic. Okay, all right. And then for example, diamond, we have a shiny solid, okay, while for the graphite we have a black solid. Okay, but both of them are made from the carbon. So that's all for the introduction for the giant molecule structures. I'll see you guys in part 2 later. So don't forget to smash the like button and also give some comment and also thumbs up to my YouTube or to my video. And that's all for the part 1. I'll see you guys in part 2. Thank you. Bye.